Welcome to IOQM 2025 paper. Okay, we will solve the paper today. Okay, and see how tough or easy it is. Okay, and I will do it in parts actually. Hopefully in 5 parts, depending on the 5 marks questions out of there. I will group them into either 2 or 3 videos. So this is part one. I will cover all the 2 marks questions. Question pattern is exactly same as last year. Okay, you have 30 questions. 1 to 10 are 2 marks questions, 11 to 20 are 3 marks, 21 to 30 are 5 marks questions. And the difference is the exam is conducted in multiple sessions this time. Okay, 4 sessions, and each session the questions are same, but the order is jumbled. Okay, in 1 to 10 order is jumbled, 11 to 20 and 21 to 30 order is jumbled just to for security reasons. That's all. So questions are same, so it's all the same paper. M1, M2, M3, M4 all is same paper. Okay, let's solve it now. 60% of a number x is 40, then what is x percent of 60? Okay, this is a 2 marks question, so I think fairly easy and straightforward. Okay, 60% of a number x is x, which means 60 x by 100 equal to 40. So x is nothing but 200 by 3. Now x percent, so 200 by 3% of 60. So we have to put 200 by 3 into 1 by 100 into 60, which is equal to 40. Right, this is the answer. This is fairly easy. Okay, find the number of positive integers n less than or equal to 100 which are divided by 3 but not divisible by 3 but not divisible by 2. Okay, this is also fairly simple questions. We know that from 1 to 100 there will be 33 numbers which are divisible by 3. Okay, that is if I put in sets form 3, 6, 9 up to 99. Okay, number of elements in S is 99 minus 3 by 3 plus 1, which is 33. Okay, so out of these 33, every alternate number is the even number. Okay, starting with odd, ending with odd, in between you have every alternate number as even. Okay, so the even numbers are divisible by 2, so we should not consider for this answer. Okay, so out of 33, 17 are odd numbers, 16 are even numbers. So these 17 are the numbers which we are looking at. The 16 even numbers which are divisible by 3, we are not interested. Okay, so answer is 17. That's answer. This is also fairly simple question. Yeah. The area of an integer sided rectangle is 20. Okay, note down it is an integer sided rectangle. Okay, what is the minimum possible value of its parameters? We know area of a rectangle is L into B. Okay, so L into B is 20. Since L and B are integers, the options we have is 1 into 20, right? 2 into 10 or 4 into 5. That's all. Do we have any other option possible? There is no other option, right? So these are the 3 options. Take the 3 cases and find out 2 times L plus B. Okay, so 2 times L plus B is either 42 or 24 or 18. Okay, out of that minimum possible value is what is asked. So minimum possible perimeter is 18. That's the answer. Okay, this is also fairly easy. Okay, next. How many isosceles integer sided triangles are there with perimeter 23? Okay, this is also a counting problem. Simple. Okay, so isosceles triangle will have 2 sides same and 1 different side. Correct. So 2a plus b equal to 23. That is the equation we are looking at. And if you see 23 on the RHS side, correct, and 2a is there on the LHS side, which means 2a is the even number. So b has to be odd number. Okay, so now this makes our work more counting more easy. We can consider only the odd values for b. Okay, we don't need to consider the even values for b. That's it. Okay, so now it's a simple counting problem. Okay, you take a and 2a plus b, then you get the value of b. Okay, so if a is 1, okay, you will get the b as 21. If a is 2, you get 19. If a is 3, 17. So you just start doing this counting. Okay, then you will get all these 11 total 11 uh, possibilities. But out of this 11, okay, why he gave this as a very tricky question? Because if you see, if a side of a triangle is 1 and other side is 21, is it possible to build a triangle? First of all, because sum of 2 sides should be greater than third side. So 2 times a is less than b, which is not possible. You cannot build a triangle up to 5, right? 2 times 5 is 10, 10 is less than 13, so you cannot build. But whereas you take 6, okay, 6 into 2, right? 12, 12 is greater than b, you can build a triangle. So only possible options are these 6. Okay, these 5 are not possible to build a triangle. Okay, so you have to remember the triangle rule while applying. So total options possible are 6. So answer is 6. Okay, this is the easy, just tricky. Be careful. Don't forget to apply the triangle logic. Next, age of a person in years in 2025 is a perfect square. His age was also a perfect square in 2012. His age will be perfect cube m years after 2025. Determine the smallest value of m. Okay, so yeah, this is also fairly simple. Let us assume he is born in year X. Okay, so if he is born in year X, 2025 minus X is equal to a square because they said a perfect square, correct? And 2012 minus X also is perfect square, so that is b square. Okay, now if I subtract these two, I get uh, a square minus b square equal to 13. Okay, now a, b are integers, we know it, right? So there is only one option which is possible. 13 is a prime, so a minus b into a plus b equal to 13 into 1. That's it, right? A minus b to a plus b should be equal to 1 into 13. Obviously, a minus b is a smaller value compared to a plus b, so a minus b equal to 1, a plus b equal to 13. If I solve it, I get a is 7, b is 6. Okay, so with this current age is 49. Okay, and we are looking at a perfect cube after this age. Okay, which is a perfect cube after this? 64 is the least perfect cube, right? So 64 minus 49, which is 15, right? So m is 15. After 15 years, his age will be perfect cube. Okay, from current year, after 15 years, his age will be a perfect cube. So 15 is the answer. Yeah, this is also fairly easy. Next. How many three-digit numbers ABC in base 10 are there with A is not equal to 0 and C is equal to A plus B? Okay. So first thing is look at the given information. ABC is a three-digit number. ABC are the digits, which means ABC can be from 0 to 9, but A cannot be 0 because if A becomes 0, it will become a two-digit number, right? So A can have 1 to 9 digits, B can have 0 to 9, C can have 0 to 9, but since C is equal to A plus B and A minimum value is 1, correct? So C also has to be between 1 and 9. Okay, now once you know these three conditions, it is a very simple counting problem. Just look for repetition so that you need not count everything. Okay, so if you see C equal to 0, we will ignore it. Okay, and C equal to 1, if C equal to 1, A can be 1, B can be 0. That's it, right? There is no other option because A minimum value is 1. Okay, so the number formed is 101. Okay, and there is only one number which can be formed. If C equal to 2, A can have 1 comma 2. Okay, and B can be B is nothing but C minus A, so B can be 1 comma 0. So always you will have one less value for B as compared to A. Okay, and A will give you the total number of possible numbers. Okay, so 2 will have two numbers. 3, okay, if C equal to 3, A possibilities is 1, 2, 3, and B can be 2, 1, 0. So you will get 3 numbers. So it's a repetition, and we can see the pattern there. So every digit, if C is x digit, then x possibilities are there. Okay. So similarly, 9, if C equal to 9, you have 9 numbers possible. So total sum is basically sigma of 9, okay, which is 9 into 10 by 2, which is 45, right? So total number of possible ABCs are 45. That's the answer. Okay. So this is a fairly simple. Yeah. Next. Four sides of a diagonal of a quadrilateral are of length 10, 20, 28, 50, 75. Not necessarily in the order. Which amongst them is the only possible length of the diagonal? Okay. So how can you arrange them? This one. And what is the possible diagonal value? Okay. So let's see. This is how a quadrilateral looks. We need to put values on these sides and the diagonal. Okay, and if you see the diagonal is actually cutting the quadrilateral into two triangles, so you can apply actually two triangle conditions. Okay, to make sure that the numbers are satisfy these conditions. Okay, so first thing is if consider the 75 for diagonal. If 75 is diagonal, then uh, you can put any number here. 50, 28 if you put here. Okay, 28 and 50. Sum of these two should be greater than 75, which is okay, but 10 and 20 will be part of other two, right? So 10 and 20 uh, cannot form a triangle with 75. Okay, so this is and you change to any other number. You take 1028, then it cannot form with 75. 1050, it cannot form with 75 triangle. So 2050, it cannot form a triangle, right? So there is no possibility of forming a triangle if 75 is the diagonal. Okay, next option. 50 also same reason. You can check all the conditions carefully. It will not form any triangle actually. There is no possibility. Okay, consider 20 as diagonal. Okay, if you consider 20 as diagonal, Okay. So 50, 20 is possible? No, not possible. Because 50 minus 20 is 30, which is greater than the third side. It should not be, that's not the way. Or 75, definitely no. 75 minus 50 is also more than, so that is also not possible. So only option is only one triangle it can form, 10, 20, 28. Other option, there is no, other triangle cannot form actually. Okay. So 20 also not possible. 10 also you can check, not possible. Only possibility is with 28. So this is also very simple counting problem. Okay, make sure that what conditions you have to apply. Quadrilateral has few conditions. Okay, whereas triangle has a better conditions and easy, right? Only three among us the numbers you have to check. Okay, if you take 28 as diagonal, we can build a quad with the 10, 20, 50, 75. Correct? So the answer is 28, and that quadrilateral formed is like this actually. You can have 10, 20, 28, 50 and 75. This is the only possible quadrilateral. Okay. So this I would say simple to medium. Okay. So easy, but it's just a counting problem. That's why I'm telling it's easy. If you have to carefully count, that's all. Next. The height and base radius of a closed right circular cylinder are positive integers, and its total surface area is numerically equal to its volume. If the volume is k pi, where k is a positive integer, what is the smallest possible value of k? Okay, which means he is asking smallest possible value of k, which means the volume you will get different volumes depending on the conditions, right? So let's see, go to the conditions first and then solve it. It is given that pi r square h, which is volume, is equal to numerically, okay, don't consider the units. Pi r h, 2 pi r h plus 2 pi r square. This is the total surface area on the RHS side. So from this I can derive a condition RH equal to 2R plus 2H. Okay. And if I take both to the other side and simply make it into products, why I want to make it into products? That is first thing. Okay. Because it is given as integer sides. R and H are integers. So if I can make a equation in of products of R and H in integers, then I know it is easy to solve it. Okay, so I get, in this case, I get r minus 2 into h minus 2 equal to 4. What is the advantage of this one? See, because r and h are integers, r minus 2 and h minus 2 also integers, correct? And it has to be product of 4. So only options I have is 1 into 4, 4 into 1 and 2 into 2. So I have to just consider the three conditions and find out my R and H, correct? So if I consider 1 into 4, case 1, so R minus 2 equal to 1, H minus 2 equal to 4, then my R is 3, H is 6, okay? And volume is pi R square H, which is 54 pi, okay? And second case is if R minus 2 equal to 4, H minus 2 equal to 1, okay? In this case, I'll get R as 6 and H as 3. Okay, and pi r square h volume equal to 108 pi. Case 3 is r minus 2 equal to 2, h minus 2 equal to 2. So r is 4, h is 4. In this case, my volume is 64 pi. What is the smallest of all this? 54 pi. So 54 pi equal to k pi. That means k is equal to 54. That's the answer. Okay. So yeah, this is also easy. It's not a very complicated, or there is nothing secret in this, right? You just write the proper formula beginning, I think you will get it, and divide it into product of two numbers, and then you will get. Next. The sum of two real numbers is the positive integer n, and sum of their squares is n plus 1012. Find the maximum possible value of n. Okay. So this one, yeah, fairly, you need to understand the number theory correctly, right? So let the two real numbers be a plus b, a comma b. So a plus b equal to n. A plus b equal to n. And also given that a square plus b square equal to n plus 1012. Okay. So now I basically want to form a quadratic equation. Okay. So I have a plus b. Let me find out what is ab. Correct. If I find my AB, then I can solve it easily. Okay, so let's, how can I find it? A plus B whole square minus A square plus B square, which is equal to n square minus n minus 1012, which is equal to 2AB. So my AB is n square minus n minus 1012 divided by 2. Okay, so once I know this is the very important step actually. Okay, so I have my A plus B equal to n and AB equal to n square minus n minus 1012 by 2. Right? So if I consider A and B are roots of a quadratic equation, I can form a quadratic equation with the given information. So which is nothing but x square minus A plus B x. A plus B is nothing but n, so nx plus AB. AB is nothing but n square minus n minus 1012 divided by 2, which is equal to 0. If I simplify this quadratic equation, this is what I'll get. Now, I know what is x. Okay, x is nothing but AB, correct? X is nothing but I'll get two values which are AB, and also I know that they are real. So which means the discriminant is greater than or equal to 0. So my b square minus 4ac is greater than or equal to 0. Just put that condition. Okay. So b square minus 4ac is nothing but 4n square minus 4 times 2 times n square minus n minus 1012, which is greater than or equal to 0. Okay. So finally I get this quadratic in n square minus 2n minus 2024 is less than or equal to 0. Okay. Which is n is n minus 46 into n plus 44 is less than or equal to 0. Uh, from this we can tell what is the range of n. N is between minus 44 and 46. Correct? N is between minus 44 and 46. And he is asking what is the maximum possible value of n, which is 46 out of this, right? So maximum possible value of n is 46. Yeah. So this is definitely a medium because the step here you need to understand from this given information, you can build a quadratic equation and then find the solution, the required solution. All right. So that's why I said at least this is medium complexity. Yeah. Next. Yeah. This is the last question of the 2 marks question series. Okay. Quadrilateral has 4 vertices A, B, C, D. We want to color each vertex in one of the 4 colors, red, blue, green, or yellow, so that every side of the quadrilateral and the diagonal AC have endpoints of different color. In how many ways we can do this? I think if you draw the diagram, this is very simple question. Okay. Permutations and combination or whatever you can apply easily. If this is my, let's say, quadrilateral, it can be any shape. Okay. Just draw it in rectangular shape. Okay, and AC is the only diagonal we are interested. We are not interested in colors of DB to be different. Okay, we are interested in colors of AC to be different. Okay, so if I can take A, starting with A can take any of the 4 colors, correct? And what C can take? C can take only 3 colors now, correct? Because it cannot have same color as A, so C can take 3 colors. Now D and B, okay, both can take any of the 2 colors because they are not, there is no connection between those 2 points, right? Those 2 nodes, there is no connection. They can have same color, they can have different color, but it should be different from A and C. So which means it can take, both can take 2 colors each, right? So what is my total number of possibilities in this way? 4 into 3 into 2 into 2, which is 48. So 48 possibilities are there. Okay. So I think this is easy, definitely. So fairly first 2 marks questions, most of them are easy. I think this is the maximum scoring here. I think 10 into 2, everybody should get 20 or 18 maximum here. Okay. So thank you. I'll do my next video with the 3 marks questions. Till then, just do maths. Thank you.